Thank you for joining this particular breakout session. If you don't know me, my name is Jeff Merrifield, and I'm a partner with Pillsbury Law Firm and also a former NRC commissioner. You were supposed to have Alina Toplinsky, my partner, who was originally supposed to be the moderator of this particular session. Unfortunately, due to airline issues, Alina's plane to get her here from Europe was delayed, so she couldn't be here, but she certainly wanted to be remembered. On the stage joining me, I have Sean Oehlbert, who is a Vice President for Corporate Business Strategy for Centrus Energy, Sean McDeavitt, who's the Director of Quadrant Nuclear and Quadrant Nuclear Industries, Alex Polonsky, who's a partner with Morgan Lewis, and Brent Berg, who's a Senior Vice President for U.S. Operations for Uranium Energy Corporation. We really want to take an opportunity. There's a lot of discussion that we had this morning about particular projects for the location of new nuclear generation. We're going to hear a lot about specific nuclear technologies, but at the end of the day, the core, no pun intended, is the ability to harness that uranium and produce power. And so you've got to have really a focus on the front end and the things that we need to be doing to provide the foundational work for uranium mining, enrichment, fabrication, and really what it takes to get us to building a more resilient fuel cycle that will enable the deployment of these reactor technologies. With that intro, what I thought I would do is open up the initial comments of each one of the panelists to why onshoring nuclear fuel supply is such an urgent issue today, and what are the things that your organization or folks that your organization is involved with doing to help fill that effort? And as you see it, where are the gaps in mining, conversion, enrichment, fabrication, and what do you think are the most critical elements that we need to fit and address first as we move into this next wave of nuclear generation? So with that, Sean, I'll start and work down the table.
Great. Thanks, Jeff. Thanks for everybody for taking the time. So as Jeff said, I work with Centrus Energy. So if anybody had seen the movie from a couple years ago, Oppenheimer, there's a scene in the movie where Robert Oppenheimer is tossing marbles into a big glass jar. And what that was reflecting was the production of fissile material for the first nuclear weapons. On the uranium side of the house, that is Centrus Energy. We are the direct descendant of the Manhattan Project, and through government privatization and restructuring, that is who Centrus Energy is right now. So we have our manufacturing facility in Oak Ridge, Tennessee. Our roots are still there. And we have our production plant in Piketon, Ohio. We are the only currently operating producer of high-assay, low-enriched uranium, or HALEU fuel, in the world outside of Russia. And we are looking to both add additional HALEU capacity as orders require, as well as deliver additional low-enriched uranium capacity to the market. And in that context, one of the things that I wanted to flag for everybody is, in the context of the low-enriched uranium market, it's important to understand two things. First, the existing market is dominated by 4 incumbent providers, all of whom are owned and backed by foreign governments. So when we think of a market, we need to understand that this marketplace is different than other markets for water bottles or pens or pieces of paper. It is one in which governments play a strategic role in the supply of material to the market. In this market, 2 of those providers are, I think, what we would consider geostrategic competitors of the United States. They are Russia and China. And the other half of that market is Western suppliers, which have been the backbone of supply to the United States and to the West for years. We have Urenco and Orno, and we need them in the market to continue to provide this material. So that's the first point. And the second point that I would say is regarding Russian material. The administration has taken steps to remove Russia and Russian supply from the market beginning in 2028. Russia will no longer, and customers in the United States will no longer be allowed to purchase material from the Russians. And in the LEU market, what that's going to mean is there's going to be a gap in supply. And we're going to need to do everything that we can, and by we I mean Centrus as well as the other incumbent Western suppliers, to move expeditiously to addressing that gap so that the existing reactor fleet continues to have the fuel that it needs. Future deployments of Generation 3 or large light water reactors get the fuel that they will need, and that the next generation of advanced reactors will have the fuel that they're going to need going forward. So with that, I'll turn it over.
Well, and again, I'll also thank you for having me here, and very glad to be here. I'm replacing Steve Winston, who was scheduled to be here. So if you were looking in the program, I don't look like him, but I look more like him than Jeff looks like Elena. So, Quadrant Nuclear Industries. Most of you have probably not heard of us because we're really less than a year old as an organization. I have been a nuclear engineer now for almost 40 years, and so the rest of our team, which is relatively small as a startup, is also very seasoned and looking to fill a gap in the uranium market, also in the HALEU space, as we are looking at establishing a facility in Idaho for reprocessing and HALEU generation in that direction. And we also have 3 other business lines, because our mission is filling the gaps in the nuclear industry. But with regard to the question of the moment, why is onshoring uranium important? That room, which is filled with close to 700 people, this is my 3rd nuclear renaissance now, I think, depending on how you count. And this one feels different. And there's a lot of companies that will be building reactors, which means we'll go from having a stable uranium flow sheet to suddenly ramping up the need beyond anybody's capacity. And so the ability to bring uranium mining, uranium enrichment, other sources of potential domestic supply is a vital component of making sure that those reactors can be built and operate. And at the same time, on this side of the aisle, we need those reactors to actually succeed and get built, or there's no reason for our companies to invest in producing the uranium that they could use. So it's very important, and to not rely on international sources becomes a matter of national security. And so from there, I'll pass it on.
Alex?
Sure. So I just celebrated 27 years as a nuclear energy lawyer at Morgan Lewis, and I would say what is happening now is unprecedented. I'm going to focus on the legal aspect of licensing, so 10 CFR Part 70 facilities. If you're looking at enrichment or deconversion or fuel fabrication, you're going to be licensed under 10 CFR Part 70. There's been bipartisan support in the past. There's currently bipartisan support now. And the executive orders that came out at the end of May are pushing changes beyond what the legislation even contemplated, which is great. On 10 CFR Part 70, we're going to see NRC issuing some draft and final rules, all planned within calendar year 2026. And I guess the question really is DOE and NRC, are they doing enough to have this front end of the fuel cycle catch up with all of the reactors that have been announced or planned or will be in development? And I don't know if now's the time, Jeff, to go into specific issues, or whether I should follow up on those.
Let's sort of do the first round, and then
Okay.
I think you posed good ideas for follow-ups.
Okay, so all the talk of reactors, that's different set of regs. That's 10 CFR 50, 52, 53, some future parts. And that's where most of the focus has been, because if you build that, that's what's going to prompt everyone on the front end of the fuel cycle to get in line. But as things stand now, today, it's great that Centrus is making some HALEU, but they're providing it to DOE. It's not a commercial supply. Even if it was a commercial supply, it's not enough for all the reactors that are out there unless we want to bring that HALEU from outside the United States, which today is politically untenable.
So let me just add a few comments related to uranium mining and processing as it relates to this question. The United States was at one time a world leader in uranium production. That really ended back in 1980, and we've seen subsequent decline in domestic uranium production ever since that time. Today, over 99% of the uranium concentrate that fuels the reactors that power a good part of the country comes from foreign sources. Now, if you look at where that uranium is mined, over 85% of it is coming from the top 5 countries, which are Kazakhstan, Canada, Namibia, Uzbekistan, and Australia. So you got to ask, is that going to continue to stay that way, or will that uranium go somewhere else in the future? So whether it's the most critical part, I wouldn't say that, but it is certainly the part that's started first. UEC and other companies have restarted uranium mining in the country today.
Yeah, just to layer on that, and then I'll go to the next question. I think Brent has made an excellent point. We just simply don't. We're at the very earliest part of the stage with milling and mining. We just don't have it there, and that's going to take a lot of attention. And I think the efforts of the administration to put a focus on that is helpful. To the question, Brent, and I think this is sort of a follow-up. Uranium Energy Corporation has restarted production in response to the demand. Can you talk a little bit about what you think are the most important steps to ensure that we have sufficient mining and processing capability, and how do we scale that quickly, if we can scale it quickly, to meet the kind of demand that you're talking about?
Yeah, so there's really 3 things that come to mind for me. The first is the actual mineral resource. So there has to be enough uranium at a sufficient grade and quantity that it make it economic for extraction. The capital and the OpEx that are going to go into the uranium mine have to be accounted for, and this is one of the areas where either you're doing greenfield exploration, or what has been more common has been acquisition and consolidation of prior projects that were discovered many years ago. UEC has been working very hard in this regard. So an example of greenfield exploration is our Berg project in South Texas. We aim to start up that mine later this year. Additionally, we've been out acquiring assets during the last uranium downturn, and have put together a portfolio of assets that have now the largest resource base in the United States, along with 12.1 million pounds of licensed production capacity. So the mineral resources first, I think. Secondly, you have to have permits and licenses, and you have to be able to get them in a timely manner. So again, we've been pretty aggressive with this. We've been permitting and licensing properties in advance of what we're seeing today, where we have higher prices. And so we have 4 permitted projects in Wyoming, another 3 in Texas that are ready to go. Finally, I think the third component that comes to mind is, so you can have the mineral resources and the permitting, but you also have to have the human resources to go along with it. And so what that means is you got to go hire the best in the industry, get them employed, There's not many out there anymore. A lot of people retired in the last downturn or left the industry. So you have to get inventive as to how you're going to onboard them, bring them into the company. At the same time, you want to take that knowledge that those people have and you want to share it further within the organization. So we've hired a lot of young people and are doing extensive training with them so that we build a deeper bench.
That's helpful. I'm going to ask you one other question, but just for the audience benefit, I will put in a plug. Later this afternoon, I'm going to do another panel with Amir Adnani, who is the president and CEO of UEC, to go, I think, into even greater depth on some of the things that you put out there. Do you want to touch? I mean, obviously, one component we haven't really talked about are uranium mills. We only have one operating uranium mill in the United States. Is that an area of focus for you all, or is that somewhat in abeyance at this point?
Yeah. So in December of last year, one of the acquisitions that our company made was with Rio Tinto. Rio Tinto is the second largest mining company in the world, and they had slowly moved away from uranium mining and processing to iron ore and other types of metals. And so we were fortunate. We bought the Sweetwater Mill, which is in the Great Divide Basin in Wyoming. It's a conventional mill, as well as we acquired the resources associated with those properties and over 175 million pounds of historic resources. So it is certainly something that we are interested in and actively advancing. Right now, the mines that we have operational are in situ recovery mines in Wyoming. So our Willow Creek operation is restarted last August. And we're building the Berg Hollow project, which is in South Texas. And again, it's an in situ recovery project that we should start up in December of this year.
Great. Let me go, Alex, to you. The ADVANCE Act, which passed Congress last July and was signed into law by President Biden, certainly was intended to catalyze licensing efficiencies at the NRC, and certainly fuel cycle facilities are no exception to that. The executive orders issued by the president back in May certainly directed DOE to be more involved in these matters: conversion, enrichment, prioritizing contracting, using authorities under the Defense Production Act, voluntary agreements to strengthen, virtually all of the stages of the fuel cycle. Can you talk a little bit from your perspective, given that as an overlay? Obviously, there's an expectation for significant involvement with the DOE and interaction with the Nuclear Regulatory Commission to try to shorten the licensing and permitting timelines for these projects. What are the barriers you see there, and what do we really need to be doing to make sure we can streamline the licensing of these activities in order to meet the needs of the advanced reactor community?
Sure. So there are, at a high level summary, regulatory and legislative hurdles at the moment, despite all of the bipartisan legislation. And I think they get into some of the minutia that aren't covered in the press, so I'll go into some of the minutia here, because that's why I'm here. So enrichment, deconversion, fuel fabrication, you've seen DOE announcements, 6 companies awarded work for deconversion. Enrichment, 1 or 2 companies awarded for that. Fuel fabrication, there's support for that through the ARDP for, X Energy on the Dow Longmont Energy project, because it includes the fuel fabrication facility. So then the question is, what can DOE do itself to license those facilities so that NRC licensing isn't needed at all? And there are pathways for that to occur, mostly on test or pilot type facilities. But once you're into commercial production or want to create a commercially a facility that's making commercial product for sale out into the market, you have to go to the NRC, even if you can be assisted by DOE by, let's say, leasing land from DOE. And so then we go to the NRC and we say, well, how does Part 70 apply and what are the hurdles within Part 70? And putting aside what the NRC may change next year, we haven't seen the draft rules, the existing rules essentially put a 9-month hold on every new facility. Because under Part 70, when you submit an application for a fuel cycle facility, other than enrichment, which I'll cover separately, you can't commence construction, which is a defined term, until 9 months after you submitted the application. It's just the way the regs are written. So I am held up with any construction at risk until 9 months after I've submitted the application. I then can commence construction at risk starting at 9 months. And the reason I say at risk is because if the NRC issues the license, however long later, and says, we're now doing an inspection on what you constructed to ensure it conforms to what the license required, if it turns out I constructed something that does not conform with the license, I have to go and ameliorate it, fix it somehow. That's why it's at risk. If I'm a uranium enrichment facility, the NRC's current interpretation of the statute is that there's no construction at risk allowed at all. So if it's going to take a year and a half for the NRC to review and approve an enrichment facility license, and I submit that application today, I can't do squat for commencing construction until a year and a half from now. So it would be ideal if that 9-month period for construction at risk were reevaluated for all facilities. For construction at risk for enrichment facilities, there's an interpretation of Section 193 of the Atomic Energy Act, which is unique to uranium enrichment facilities. So we can't push the NRC to say, hey, you need to do this if the NRC is saying our hands are tied, the statute needs to be changed. So obviously it would be ideal if not only the 9-month provision was removed, but the interpretation for enrichment facilities was either made concurrent with the 9 months for other types of fuel cycle facilities. There also is the issue of mandatory hearings. You may have heard that for reactors, that reactors have to have mandatory hearings, and those mandatory hearings need to be complete before the NRC typically will issue a license. There is draft legislation. It was introduced before. It was just introduced again this year, I think in May of 2025. It's essentially the nuclear licensing efficiency. Senator Scott and others introduced it, and it would remove mandatory hearings not only for reactors, but the last part of that legislation would also remove the mandatory hearing, which is currently only required for uranium enrichment facilities. All the other fuel cycle facilities don't need a mandatory hearing under the Atomic Energy Act. So those are the kinds of changes that would be ideal. And there's no security or safety risk that I'm aware of for holding off starting construction at risk. Look, we're an entrepreneurial society. We are taking risks all the time. These are not safety risks. Why? Because you're not allowed to possess the special nuclear material or other nuclear material at the facility until the NRC issues the license. So let these companies move forward and construct. Then they can wait to get the license to actually possess the radiological material. So the community can't be possibly hurt by a nuclear accident, which has not gone through an NRC review or for its safety analysis, because there's no nuclear material on site at all. I'll stop there. Thank you.
Yeah, I just want to layer on that just for a moment. You know, I'm reminded the mandatory hearing process is one. I called, as others did, for the removal of that back when I was an NRC commissioner back in the mid 2000s, and I think looking at it with some degree of optimism. I mean, there are a number of changes that have been made at the NRC, and the statutory changes that I think have enabled greater flexibility. But I think many of those have been focused on the reactors, and obviously the mandatory hearing one is got to be addressed. But I think I agree with your points. I think more focus on how do we, either through legislation, regulations, or both, enable the ability of these types of facilities to move forward more quickly. The one two additional points I would make is we are in an area of uncertainty, because the administration called for a reassessment of the NRC's entire regulatory process. And there is a team of individuals under Doge and otherwise who are sort of working away on some thoughts on that. They recently brought in a couple of law firms to assist them, neither of the ones that we work for, a couple that I don't know if they have any new experience, but nonetheless working on trying to improve that process. But we don't really know what that looks like. That's being done in a very non-transparent way, and we'll sort of all find out probably around February what that looks like and how we're going to respond to it. So it does add a degree of uncertainty. But I do want to go back to a more positive point, and that is the NRC certainly has taken attention to the ADVANCE Act and is being more flexible in considering opportunities and where law firms and their clients are coming in with exemptions. We're seeing a greater willingness to take that on board. So I think this is an area where there is opportunity for creativity, and we certainly have to try to engender that on our part. Speaking of creativity, Sean, I want to go to you. Obviously, Centrus is committed to restoring U.S.-owned enrichment capabilities, and you have been working very closely with DOE regarding some of the recent incentive programs to try to get HALEU back online. You've got a design of a centrifuge you've been working on for a long time and have tested and is well along in its deployment. Can you talk a little bit about what the company's done to really go from more of that pilot scale HALEU program to really engaging in a large way to produce the kind of HALEU production we're going to need for these bevy of advanced reactor designs that are calling for the use of that material?
Sure. Thanks, Jeff. Just to echo the theme on NRC licensing, we are an NRC licensed facility, and we have going through the licensing process, we had a very positive and productive relationship with the NRC in securing our license, and we continue to have a positive relationship with them. So I understand that there's some challenges, and Alex is obviously, I think his intervention demonstrated that he's way smarter than me on these issues. But we found that early engagement and ongoing engagement with the NRC in the context of securing our license and then in the implementation of our license has been positive and constructive. So I just want to put a plug out there. They should not be necessarily viewed as a hindrance. I think that, to address some of your question, yes, we have been in operations for HALEU production now for over 2 years. We just passed the 2-year mark in our contract with the Department of Energy. And so we are looking to expand our productive capacity to meet market demand, as well as bring, as I echoed in my earlier intervention, additional low-enriched uranium capacity to market that we're going to need for the existing fleet and that we're going to need as feed for HALEU production. Mm-hmm. But listen, I can talk to you all day about my company. I'm happy to do so, but I'd like to take a little bit of a step back. So I think part of what I view this panel and this conversation as being, how do we take the discussion that has been taking place in the big room this morning and actually bring it into reality? And I want this to be considered to be productive if it is a little bit sobering. I just got back from Paris last month. Jeff was there with me. I was speaking on a panel with the CEOs of Cameco, Urenco, and Orono, and Quadrant. And while we disagree on issues pertaining to low-enriched uranium, we generally agree on issues pertaining to HALEU, which is basically, don't blame us. Don't blame us for the lack of capacity. Mm-hmm. We do not operate on the field of dreams approach. If you build the capacity, the customers will come. From an enrichment side, we will have capacity online well before the reactors are online. But in order to do so, we need one of two things. We need bankable contracts from creditworthy off-takers, or we need governments to step in and help defray the risk to enrichers through various funding programs. Now, we are starting to see slowly some contracts that are bankable. Our competimates over in Europe, Urenco, have signed 2 small contracts with advanced reactor developers. And the reason that they were able to do that was because the British government funded them to start building capacity over in the UK. The US government is sitting on several $billion that they're about to announce for awards to do exactly what I just described, help incentivize production for HALEU and LEU through government resources. Keep in mind what I said earlier. This is a strategic market in which all of the incumbents are owned by governments. There is a role to play for governments here. And bringing it back to the topic of this conversation, when we're talking about taking that conversation in the big room and actually bring it into reality, we have to recognize, do we want to rely exclusively on global suppliers to power what we're trying to do here in the United States, whether it's bring more electrons to the grid, power data centers, process heat? The administration has announced that it wants to be energy dominant in a situation of energy abundance. Well, what we need to do that is be investing in American capacities so that we can be less reliant on global supply chains and less reliant on foreign suppliers. We see that in the uranium mining and milling industry. We need to bring more of that online. We need to bring more enrichment online. We can do that by, on the supply side, with the US government adding money like I talked about. We also need to be considering demand side mechanisms to incentivize the customers, whether they be utilities, off-takers, industrial applications. How do we consider and figure out to incentivize the demand side of the market to be making selections and signing contracts? Those are key things that we need.
Great comment. Let me pivot to Sean McDeavitt. You obviously have had extensive experience both in academia and industry. There's obviously an important nexus between research and development and demonstration programs. I think DOE's HALEU availability program that Dan talks about, some of the announcements we're going to have are going to show that some of that some of those demonstration programs can be leveraged to create a sustained commercial market. But I'm curious, from your viewpoint, what metrics or milestones would demonstrate that domestic fuel production is moving beyond that demonstration toward scalability?
Okay, so let me preface the comment a little bit with a mini bio without talking about myself too much. I worked my first 11 years at Argonne National Laboratory. So it's not just industry, I also worked at the national labs. So Argonne for 11 years developing with me and 100 of my friends, developing the pyro process stuff that's out there being talked about by our companies out there. And then I went to academia for the last 25 years. I left in industry, but I did a lot of industrial research as well. And so I was doing nuclear fuel qualification, nuclear fuel materials and processing and behavior. So in that space, the interesting difference between a national lab, a private company, and a university, I use the phrase attention span. What I mean by that is that if you fund a university professor, it takes about 2.5 years for that grad student to know what he's doing or she's doing, and then in the last 6 months they do everything. And so it's a hockey stick curve on productivity. If you go to the national lab, we worked on the congressional budget cycle, and I think we've been on a continuing resolution in October since the 90s. And so it was always a 1-year budget with a 6-month adjustment. So the attention span was shorter. And then I've been in industry now for only a whole 6 months. But we like to joke that we don't make it to Friday with the same plan we had on Monday. So our attention span is much, much, much shorter. And so the pace of dialogue can make universities' involvement less relevant unless pieces that are useful. And I've worked in projects as university projects. I'm not saying universities are useless. We're not useless in the R&D phase. But that is not where industry happens. And national labs are not either. And so the innovation, the risks taken to fund and deploy and work with the licensing, that's on the back of the industry. And so when you get to what are the milestones, what are the things that need to happen, we're in this chicken and egg moment we were talking about before the panel. If you're a HALEU producer, and you mentioned it too, if you're going to be a HALEU producer, you need a HALEU user. And so these different, somewhere between 100 and 200 reactor companies, some of those actually have to build reactors that use HALEU, or there's no need for us to invest in the projects we're doing. So the milestones advance while it looks really good, and it's looking really good right now, and work with the NRC on the regulations. And so all those factors need to keep coming in, but it's sort of like holding water in your hands as long as there's no reactors. And so that's, I guess, my first answer to your question.
Great. Let me, and these will be shorter because we are running short on the time for the session. But it would not be an event of the Texas Nuclear Summit unless we had a Texas-focused question. And so Texas is home to a variety of major uranium resources. Obviously, we heard talk of some that may be open soon. How do you all see Texas contributing to the fuel cycle, and what are the unique challenges and opportunities that exist here as compared to other states? And I'll start.
Okay.
At the end.
Oh, okay.
All right. Can you hear me? There we go. I think, Texas is clearly an energy state. It's got an experienced workforce, a strong industrial base, and a legacy of energy innovation. So, I think it could clearly be a rising star in terms of the nuclear challenge before us. In terms of what challenges come to Texas, the one that's top of mind for me is water, and that can certainly play a factor in regulatory or community acceptance. The one thing I would observe, though, that's different in Texas than other states that we're operating in is what we see here today. So you've got a grassroots effort to bring industry, government, academia all together for nuclear. I can tell you, I'm in Wyoming all the time, and although there's all kinds of support for nuclear there is no grassroots effort driving it like there is in Texas. So I think there's something magical about what's starting to happen here, and I see good things ahead for Texas.
I think we're seeing an appetite from the academic community to host facilities that we don't see in other states. UIUC might be having a single microreactor. We're seeing 3, 4, 5, 6 out of the Texas academic university system. There's also, if you look at Fermi America, where are they located? They're adjacent to the Pantex plant. So you have community acceptance, you have workforce that already has clearances, you have workforce that knows nuclear and isn't afraid about nuclear. So there seems to be an appetite that is, no surprise in Texas, larger in this state than in other states that we're seeing. Clearly, you look at Idaho and Idaho National Lab, there's a plethora of reactors being developed there, but it's very isolated at INL. The kinds of projects you're seeing in Texas seem to be statewide.
Mm-hmm. So before I left A&M, I was working with the university system. I was part of the team that was bringing these reactors to the Rellis campus. And the thing I just said a few minutes ago, we need these reactors to build. We raised our hand and said, come build your reactor here. And so the enthusiasm from the governor down, I was actually on the working group 2 years ago that governor established through the PUC. And the enthusiasm in Texas to be that leader, to come and recruit industry to come here to build, this is what makes this nuclear renaissance feel different. And it's really big here in Texas, no pun intended. But the enthusiasm and the invitation here and the actual reality that some or all of these will be built is it's a game changer.
Sean?
Yeah.
Last comment.
Yeah, I don't have too much to add. My colleagues mentioned many of the notes that I took here. The way that I look at it in Texas is echoing the theme that I made about the demand side. From the governor on down, putting in place the mechanisms that are needed to draw the industry to the state, build upon what's already going on here. Texas A&M is a hub for nuclear energy, the Natura project. You're seeing all of these demand side pulls to come to Texas come to fruition, which is going to make it easier for the industrial side, for the companies that are reflected on this table, American companies, to put in place the infrastructure that's going to be needed to support these projects.
Great. Well, there's certainly a lot of interest in Texas. I will say there's a huge amount of interest in a lot of different states, and competition's a good thing, and so let it go. With that, I want to have you join me in thanking our panel for their comments this morning. All right. All the best for